Alright, so verifying trig identities. This is very similar to what we just were talking about. But now, instead of an expression, you're going to have an equation. And all you're going to be doing is um, you're just going to be making one side equal the other side. Okay? So you notice here I have from page, whatever that page was again. Alright? We have that. So example 1. Part A. We want to verify that secant squared of theta minus 1 divided by secant squared of theta. We want to verify that that is equal to sine squared of theta. Alright? And what we do is we're going to look over here at our chart and we're looking to see, is there anything that can help us out? Alright, so is there anything that can help us out over here? So I have secant squared minus 1, and I'm looking to see if I have anything secant squared minus 1. Now I have this Pythagorean identity right here. If I subtract the 1, I have secant squared minus 1. But the only reason why I'm kind of holding off doing that is I'm looking at this thing and I said, well, let me do a little bit of algebra to this. I look at secant squared minus 1 over this. I'm saying I can rewrite this as secant squared theta divided by secant squared theta minus 1 over secant squared of theta. Right? And the whole time I'm trying to make sure that it's going to equal the sine squared theta. Secant squared of theta divided by secant squared of theta cancels itself out. We're left with 1 minus 1 over secant squared of theta. Well, 1 over secant is right here. Alright, so 1 over secant is equal to cosine. So I can actually write this as cosine squared of theta equals. And again, I'm still trying to make sure it equals sine squared. Now I'm seeing 1 minus cosine squared of theta, and I see that thing right there, that trig identity. Cosine squared of theta. Right, let me move this out of the way for a second. And I have cosine squared of theta plus sine squared of theta is equal to 1. Do you agree if I subtract cosine, I end up with sine squared of theta is equal to 1 minus cosine squared of theta? Alright, so then I can take this and replace it right here. I can replace that. So then, in fact, I have sine squared of theta is equal to, and I brought all the way down, sine squared of theta. So that identity does check out. Now, if I would have went this route with this, could it have worked also? Yeah, but I think seeing this sine squared theta over, seeing this secant squared theta divided by secant squared theta kind of helps out, because anytime I have a monomial in the denominator of a fraction, I can separate this and I can take this thing and put it with that and put it with that. Okay? So I just wanted to use a little bit of algebra there. Alright, let's try another one. And again, I apologize for dragging this thing all over the place, but it helps. Alright, let's look at another one. Part B. We have secant of x. Now, x and theta, exactly the same thing, plus tangent of x is equal to cosine of x over 1 minus 1 minus sine of x. Now, it does not matter which side you go with, but I want to show you guys this right side because I don't want anybody making the mistake of saying, oh, I can take this this 1 and put it under cosine of x, and then taking this negative sign and putting it underneath cosine of x. We cannot do that. Like that last example, it only works if you have a monomial in the denominator. Alright? So what we're going to have to do here, in order to get rid of this denominator, I have cosine of x over 1 minus sine of x, and you notice I'm not writing anything over here, times 1 plus, well, maybe I should make this one just a plus in red, 1 plus sine of x over 1 plus sine of x. Alright, now, what happens when we distribute? Cosine times 1, still cosine of x. Cosine times sine of x gives us cosine of x, sine of x, over double distributive property in the denominator, 1 times 1, 1. 1 times sine of x gives me positive sine of x. Now I have negative sine of x times 1. And you'll notice what's happening with these two things. These two things will cancel each other out. And then I still have sine of x times sine of x. So minus sine squared of x. It's looking like a big old mess up here, but let's clean it up. Cosine of x plus cosine of x plus cosine of x sine of x all over 1 minus sine squared x. So far all we did was just algebra. That's all we did. We have yet to do any trig. We have yet to do any trig here. Now comes the trig. I see 1 minus sine of x. Now I'm looking over here at our trig identities. Sine squared x with a 1. Do you guys agree? If I were to subtract that sine squared, I'll end up with cosine squared x. Alright, I'll give you a second. Do you agree? Now, the numerator. Cosine x plus cosine x sine of x. Right, this problem is fairly long and involved, but hang with it, you can do it. Let me drag my identities over here with me. Alright, now Now that I just have a monomial in the denominator, now I can break this up. Cosine of x over cosine squared of x plus, right? And I'm getting that plus from right there, plus cosine of x sine of x over cosine squared of x. Well, I have one cosine on top, I have two on the bottom. So this cancels out one of those. I'm left with 1 over cosine of x plus, again, one of those cancels out one of those. So I'm left with sine of x over cosine of x. One over cosine of x. 1 over cosine of x. Where do we have this? 1 over cosine is equal to secant. So secant of x plus sine of x over cosine of x is equal to tangent. So plus tangent of x. Now if I scroll way back up here when we first started, what was this mess? Secant x plus tangent x. Secant x plus tangent x. Secant x plus tangent x. So that one checked out. Okay? Let me drag this here so you have something to look at, because now I'm going to give you guys a problem or two to try. Part C. You try it. Cosine of x times the cosecant of x times the tangent of x equals 1. So I want to take all of this mess, I want to take all of that stuff and prove that it equals 1. Alright? Give it a try. Hit pause, you try. Alright, so I hope you gave it a try. Cosine of x, I can't do anything with it yet. I can't do anything with cosine of x yet, so I'm just going to rewrite it. Cosecant of x is 1 over sine of x, so times 1 over sine of x, and then tangent of x, I think by now you guys know, is sine over cosine. Well, let's think about multiplying these two right here. This is simply cosine of x over sine of x times sine of x over cosine of x. And again, we're still trying to make this thing equal 1. I hope you guys all agree. That cross cancels. That cross cancels. So we're left with 1 equals 1, showing that checked. Alright, one more. And I hope you guys are actually trying these on your own. I hope you're actually hitting pause, giving it a try. Okay, last one. Let's make it a little bit uglier. Tangent squared x plus 1, and again, x and theta, exactly the same thing. It's not that big of a deal. Times cosine squared of x minus 1. We want to show that it's equal to, that it's equal to negative tangent squared of x. You give it a try. Hit pause. And the hint I'll give you, you have a binomial times a binomial. Alright, hit pause, you do it. Alright, the way I would start this thing, I would say, alright, tangent squared, sine squared of x over cosine squared of x plus 1. I'm just rewriting it because the only reason why I'm rewriting it is because I already noticed when I multiply those two together, I'll be able to get the cosines to cancel. So that's the only reason why I rewrote it. Alright, so when I do multiply, do we agree this and that will cancel? And I'm left with just sine squared x. Alright. Now, sine squared x times negative 1, well, that's simply, oops, that's simply minus sine squared x over cosine squared x. Now, distribute down here. Plus cosine squared of x minus 1. Alright. So we start looking at this and say, alright, there's really nothing left for me to do except if I write this one and this one right next to each other, sine squared of x plus cosine squared of x. Do you agree? I have that Pythagorean identity. Okay, so that's the reason why I wrote it next to each other. And then I'm just going to bring the rest of the stuff down for now. So sine squared of x, we already talked about that. That's right there. All this stuff is equal to 1 minus. Now, I can't do anything with this sine squared x, cosine squared x. And I'm noticing that I have tangent over here. So I said, well, I'm thinking, let me just rewrite it back to tangent squared x minus 1. Well, positive 1 minus 1. Sorry, I'm getting carried away with all these colors, but those cancel. Minus tangent squared of x is equal to minus tangent squared of x. Alright, so I really hope that you're trying these problems because you have to go through and do some thinking. Alright, you have this whole trig function identities